Focus up. Hands folded out of me. Good morning, Duke.
Good morning, Mr. Reese.
All right, all hands should be folded, all eyes should be on me. All right, today's do now cheat is Jasmine. Everybody give Jasmine a hand clap. Give her 2. All right, so Jasmine, I want you to either choose to explain or call on someone to explain how you plotted the points for number 2. Or 2. All right, go ahead.
So what she did was she had to read the part and then she read the number. The first number was the first letter was A, but the A was -4 and +2. So first she had to go to the x-axis and then she had to look for the -4. And then she went up to, and then she marked her point A. And then she went to the next one, B, and then she looked, she didn't see B on the x-axis, so she had to look in between 4, and then she got 5 right there, and then she went up 2 more, and then she marked B. And then right there you can connect the dots, but you're not finished yet. And then she went to C, and then she had to go through 4. She had to do 4 and -4 and -4 and -3. So first she had to go, then she had to go down. She don't go up, she got to go down. And then you mark it between 2 and 4, and between 2 and 4, so and that's 3. And then you can connect A to C if you want to. And then you have B, and it's like 5, and it's +5 and -3. So you got, and then if you put and mark your B right there, and you connect it together, and you get the first page.
Excellent, very good. Jasmine, do you want to explain or pass it off for finding the perimeter and the area of the shape?
I explained it.
All right.
So for the area, what I did was I could have. I added the boxes on the inside, and well, I first did the first line, and that was 9, so I counted by my 9 all the way down, and I got 45.
Okay, so you did 9 plus 9. I'm just trying to understand how you did what you did. So 9 plus 9 is what?
9.
Okay.
Plus 9 again.
So 3 9s or 2 9s? Let's look at the shape. How many 9s?
2.
Mm-hmm.
And this 18. And then 5 plus 5 is 10. And we're going to say 18 plus 10, which is 28.
Very good. And do we say units or units squared for perimeter? Units. Very good. And then for area, do you want to pass it off or explain? All right. Hands raised.
You're just going to take, you're going to take 95 and multiply with 45.
Excellent. Is it feet?
I mean,
Very good. It might be feet. We don't know. But when there's no units specified, we make sure that we use the general term, which is units. Excellent. Jasmine, explain or pass off for number 5. All right. Big voices.
Alright, so you know that -19 is the same as 590, so the first one is 19. For the second one is 2,000, and 2,000 is still equal to 2,000. And 36 is still equal to 36, so it's from 36. And -45 is the same as +45.
Excellent. So someone define absolute value. What is the definition of absolute value? Waiting for a couple more hands. Definition of absolute value. Great one.
Places away from 0.
The number of places away from 0. And someone tell me, is absolute value positive? Is it negative? Is it both? Someone talk to me about what the sign of absolute value is. Jeremy?
It's both.
Okay. You think it's both? Why?
Not the sign, but the answer.
The answer could be both. Okay? I'm making an observation. I see that all of her answers are positive. To mine? It's always positive, all right? Everybody say positive distance.
Positive distance.
Away from 0.
Away from 0.
Okay, so we know that the absolute, I'm glad that we reviewed that. The absolute value is the positive distance away from 0. Very good. All right, someone tell me what is the definition of a polygon? Definition of a polygon. Amaya?
The definition of a polygon is a shape with all straight sides and it's closed.
Excellent. It's a shape with all straight sides and has to be closed. Very good. And why is this not a polygon? Jabbar? Very good, because all the lines are not straight. And the last question. Jeremy on the lacrosse team is saying that the distance between the lacrosse field and the school building is negative 45 yards. What do you think? Waiting for some new hands. He says the field is negative 45 yards away. Destiny? That is the distance between the lacrosse field and the school building. Now someone tell me, is that correct to say it's negative 45 yards away? And I am.
No, it's
No. We always describe distance as positive. Everybody say distance as positive.
not. Distance as positive.
All right, very good. Any questions about the do now before we move on? All right, turn to the back side and slant, please. And I need someone who is slanting to do the objective for today. Alicia, big voice.
Absolute values, polygons, and scale drawings in order to calculate the difference between real-world location, whereas on
Very good. All right, so who would like to tell me what you want to annotate about that objective? What are the key ideas, the important things that we're going to pull out of that objective? We're going to underline it in our notes. Taylor.
We need to underline coordinate plane and railroad locations.
Okay. Coordinate plane, real world locations. What else should we underline? Dion. Polygons. All right, let's underline polygons. What else? Shakia.
We should underline absolute value and scale drawings.
All right, very good. Absolute value, scale drawings. Anything else? Dion. Distance. Absolutely, absolutely. Very good. All right. So the key idea that we're gonna use today is that we're gonna use what we already know, what we reviewed on the do now, with coordinates, absolute value, polygons, and distance. And what is new here is scale drawings. Everybody say scale drawings. So we know we're gonna do something with scale drawings, and it's gonna have to do with real-world locations. All right. All right. So we're going to first think about today. We're doing a coordinate. We're going to be doing scale drawings. We don't know what those are yet. All right. We don't know what scale drawings are yet. All right. But we know that it's going to be very important when we're looking at real-world maps. Everybody say scale.
Scale.
Okay? So when you're given a map, it's always going to tell you what each of those little squares means. It's going to tell you the length of each of those little squares. So here, someone raise your hand and tell me what is the length of each of the little squares. Jerome?
20 miles.
20 miles. Very good. Up until now, we didn't know if it was miles, feet, yards, but now that we know that each of those little squares is actually 20 miles. So who thinks you could tell me what is the distance from here to here? If each little square is 20 miles. If each little square is 20 miles, what's the distance from here to here? Jen? 100 miles. How'd you come up with that? Count by 20. Very good. All right. So she counted by 20. 20, 40, 60, 80, 100. All right. So we know that the distance from here to here is 100 miles. All right. Someone summarize what we did and how we did it. I love this. That's from the same people, and those individuals are about to get some character marks. Love to see some new hands as well. Yeah. The question was summarize what we did and how we did it.
First, we plotted the points, then see the distance, like the absolute value, to see what the distance was.
Big
Then
question.
we did the scale, and then we multiplied it, then we did multiplied by 100 miles.
Excellent. Excellent. Very good. All right. So let's flip back to our notes, and we're going to fill in some key points for today. Everyone's looking in your notes, and we're filling in these points as we go along. All right? All right, number one, locations of real-life objects or places can be represented on a coordinate plane. Number two, when these objects or places are drawn in proportion to their actual size, this is called a scale drawing. All right, so that drawing that I just had up on the board, where the plane began, where it ended, the distance between it, it was a scale drawing because it said that each little square represented 20 miles. Scale drawing. All right, so when these objects or places are drawn in proportion to their actual size, this is a scale. This is called a scale drawing. All right, now, obviously, when we're looking at this paper right here, that distance is maybe like 3 inches, right? But we know that this plane didn't fly 3 inches, right? So what we know that each little square isn't just that length. That little square actually on this picture represents 20 miles, right? It's not like the plane just flew this far, right? The plane flew 20 plus 20 plus 20 plus 20 plus 20, 100 miles, all right? Any questions on that? All right. A scale, a scale can show the relationship between the units on the coordinate plane and the distances in real life, right? So this section of any scale drawing is the most important section because it tells you exactly how much each little square represents, right? That little square could represent 10 feet. It could represent 3 blocks in your neighborhood. It could represent 100 miles, right? But you don't know until you see the scale, all right? So the scale shows the relationship between the units on the plane and the distances in real life. The distance between points is represented by a positive value. You're filling this in? Distance is positive. Everybody say distance is positive.
Distance is positive.
All right, get that down and then track. This right here is the most important part of the lesson. This right here is the most important part of the lesson. There are 2 methods that we're going to choose from. You get to choose when you're solving these questions which method you're going to use. All right, someone read the first method that you could use to solve questions like this. Take it.
To find the distance between points on a coordinate plane, count squares on the grid and multiply by scale.
All right, so we can count the squares on the grid, and then we can multiply by the scale. That's what Jasmine did. She said 20 times 5. She was listing her multiples of 20, right? Was 100 miles. All right. And what is the second method? What is the second method that we can use to find the distance between points on a coordinate plane? Jerome, big voice.
A different was subtract the absolute value of the coordinate and multiply by the scale.
All right, so we know that we're always going to multiply by the scale. All right, at the end, we're always going to multiply by the scale. But what we do first is up to you. You can either count squares on the grid, or you can add or subtract the absolute values. You can add or subtract the absolute values. All right? Any questions before we move on? I think this makes more sense when we see an example. Yes?
This is so easy. Why does it look so complicated?
What part of this complicated?
Up here, like I said, like, I don't know why it looks complicated. It looks complicated.
All right, well, let's see if it's complicated once we look at example 1. All right? All right. Yes, Shakia, everyone should be tracking Shakia. Let's see if we're going to get a point with Shakia. Everyone should be tracking Shakia.
First, I'm understanding the 2 methods we can use, but which one makes more sense? I know you said I know you can use one of these 2, but which one is like the simple, easy one?
That's an excellent question, and Shakia has a curiosity mark for asking that question, deep in understanding. So, which of these makes more sense, all right? I think it depends on the question, right? Sometimes it's going to be very easy for you to just count the squares and then multiply by the scale, right? Other times it might be more difficult to count the squares, or maybe the picture's not clear, and so you want to use this second method, okay? All right, does that answer your question? All right. All right, let's flip to example number 1, and I'm going to think out loud for you. For example number 1, I need a volunteer to read example number 1. Jeremy.
Almost all sophomores earn their way to the Olympics. You get to see the noise. They walk together.
All right, very good. So we're trying to figure out what is the distance from the light rail to Camden Yards. So I'm going to think out loud for you so that you know exactly how to do example 2 in a second. All right? So it says, I see that it says the distance that they travel on the light rail. All right? So I don't need to include this first distance because that's them walking to the light rail. Right? When they walk to the light rail, then we're moving on. What I do need to include is this distance from the light rail. I'm going to draw a straight line down to the x-axis. And I have to break up this distance. into 2 parts. So the first part is coming from the light rail to the x-axis. And the first time I do this, I'm going to use the counting squares method that we talked about. So I'm going to count the squares. 1, 2, 3, 4, 5, 6. So I know the distance is 6. All right? Then I know that I need to get the rest of the way home. I need to get to Camden Yards. So I need to go down and look. I count 1, 2, 2 more units. All right? So I know that that total length is 8 units. All right. Now I'm looking over here at the 2 options that I have, the 2 strategies that I can use. And it says count squares on the grid. I did that part. But then it says multiply by the scale. I have to multiply by the scale. So the total distance was 8. But then I need to multiply 8 times the scale. Raise your hand if you see the scale. Raise your hand if you see the scale on this.